Welcome back to Chain Reaction, the Foreign Policy Research Institute's flagship network of podcast series examining the political, security, economic, and social trends shaping our world. Throughout the year, we'll be talking with experts about developments in Russia's war in Ukraine, the new European security order, defense and geopolitical issues in the Baltic states, as well as current and future national security challenges and opportunities in the technology and space sectors. Join us each month for
Bear Market Brief,
Behind the Front,
Baltic Ways,
Report in Short,
The Ties That Bind, NATO Allies in Action. New episodes are available each week on Apple Podcasts, Spotify, and most streaming services. To be the first to know about new releases, you can subscribe to FPRI's Insights newsletter. That's fprinsights.substack.com, or follow the link available in the description of this episode. Thanks for joining us. This week on Behind the Front.
drones. The word is everywhere. Are they the future of warfare? Should the United States be buying more? Are there lessons from Ukraine that are applicable to Taiwan, where China may invade in the near future? To discuss this topic, I sat down with Lorenz Meyer, who is the founder and CEO of Aterion, who have been at the forefront of developing drones, particularly their operating systems, and has experience both in Ukraine and Taiwan. Enjoy the show. Lorenz, it's great to have you on the podcast.
Thank you for having me.
Well, I have to let our listeners know that we were introduced by FPRI Senior Fellow Rob Lee, who I think you know from your trips to Ukraine. So, in keeping on the theme of this podcast, Chain Reaction, perhaps you could tell us a little bit about the work you and your company have been doing in Ukraine and how you came across our Senior Fellow Rob.
It's quite an interesting story because I've actually never scheduled to meet Rob in Ukraine.
For people who know Rob, that's more or less on point, but sorry to cut you off.
But we ran into each other 2 times on the train to Kiev, completely unscheduled, in the queue, in the same spot, in all of our gear. And I've made a point to be very regularly there. I do believe that a lot of companies, and I will come back a little bit to sort of the origin story of the company and how we got into drones, but I do believe a lot of companies are kind of shipping kit forward, thinking they know how it works. And we took a very different approach, a very humble approach of basically saying, well, we know that we don't know. And so we have to start by contributing, or in fact, figuring out if we can contribute at all to defend Ukraine by going there and asking questions around what do you need, what doesn't work, what is the local industry currently not doing or not great at doing. And in many ways, that's actually a similar approach to the approach of Rob in Ukraine. It's initially, I was much more I would say, national security and defense thinker, warmonk, than actually CEO or developer. And so what we quickly realized is actually the ecosystem is thriving and developing really, really quickly. And I met a lot of great Ukrainian drone companies and founders that did incredible things in absolutely no time. But one of the things they're kind of forced to live, and anybody who has been in Kiev and has seen the feverish paces, it's actually hard to drive towards a North Star in a longer term roadmap. You live very much in the moment. And so we thought okay, what we can actually contribute is taking on some of those harder problems. And so about over a year ago, 1.5 years ago, we realized jamming is an issue. I mean, surprise, surprise.
Right.
What are the solutions to jamming? And one part of the solution is to lock onto the target from a distance with terminal guidance and strike the target. And so if you get jammed the last couple hundred feet, couple hundred yards, doesn't matter. And it also helps with radio horizon, which basically means there's earth curvature, there's terrain, there are forests, whatnot. And so you can't, with an FPV drone, you can't actually always, with manually flying it, get really close to the ground and close enough to hit the target without a drone repeater or other means. But if you can lock onto the target from some altitude, let's say 300 feet, 500 feet, now you can fly much further because your radio signal doesn't get obstructed. That's a radio horizon by the terrain. And so initially it was like, I think the first 6 months or so, it was all about learning and then building a product from scratch for that need. And I call this the true forward deployed engineering approach. I think the term is being overloaded. Like I think my like probably three most disliked terms are forward deployed engineering, AI,
we'll get along,
because it means
friend.
everything and nothing, and swarming. Because we do all those three things, but I think there's a lot of fluff around them and a lack of definition and a lack of defined performance.
So let's take a step back. So you're watching the war unfold. You decide to go to Ukraine, but you do have a commercial incentive. You're thinking that you're seeing these FPVs sort of proliferate around the battlefield. And so what's your incentive structure to say, I want to take myself to a war zone? I mean, other than I want to build a company so that I can make FPVs or sort of aspects of FPVs. What's your incentive structure?
So there's a personal and a company incentive structure, and I want to be like ultra transparent about that. Of course, in the current day and age, it's the fastest growing part of the drone industry overall. And we do cargo, we do inspection, we've done a lot of civilian use cases. We've been also working the last 8 years with DoD on short range reconnaissance, longer range reconnaissance, open architecture, all that. So defense is not new to the company or to me, but I think two things were fundamentally new. Number one, being comfortable with loitering munitions. Mm-hmm. And not being just comfortable, but like embracing them as absolutely necessary.
As a company or as a moral thing? Because sometimes people during this loitering munitions debate were concerned about killer robots not operating with humans in control.
I don't think you can divorce these like things. Like you can't take them apart. There is always a moral element to technology. I have a very pointed view on that. I'm a technology optimist. I will get to that in a second. I think it's a valid and important piece to talk about. But like for me personally, the journey was, well, apparently we're back to large-scale land wars that we all thought are over. I think the important piece is there has been war over the last decades. Obviously, we've seen all, and there are different. I'm sure there are different viewpoints on the necessity for each individual theater. But what is fundamentally new and what for me makes this different is it's not close to NATO. That's also part of it. But the more important thing is it's a massive territorial expansion with, if all of Ukraine was the ambition, which I believe it was, that we have not seen in 80 years. It always was some sort of local ethnic component, a question of the governance system and or ethnic concerns. But the size of Ukraine, thousands of square miles, territorial expansion with a declared need to have more territory, that is fundamentally new. And I think that changed a few things for me and for others around our view on the world, because that seemed like a bygone era. And so like my willingness to travel to Ukraine is directly related to that. I think it's a fundamental new era where you have to decide, like, are you ignoring that? Are you standing in for values? What are those values? And that then also guides what I'm willing to do or not do.
And so when you get to Ukraine and you start asking these questions, one thing that the Ukrainian armed forces have been lauded for is extreme innovation in terms of, or let's say rapid iteration of how they're going about fighting on a daily basis. I also think it's fair to say that when you look at their FPVs, there's no standard FPV, right? Some are being given by volunteers, some are being given by wealthy sort of individuals here in the United States, I assume also in Europe as well. And then some are being procured by the Ministry of Defense. And then obviously now they've had their own indigenous FPV system grow up within the conflict. And so you have all of these different machinations of weapon being used. So what's your thoughts on sort of the different types and how you can fit into this, I guess, emerging ecosystem.
So I think you've given me sort of the almost ideal segue to talk a little bit about my own background and history. So 17 years ago, I've created as a bachelor student the today de facto standard for drone communications called Mavlink. And I did so with a very short tactical need of needing to design a protocol that I could use in a student competition around drone autonomy, which was brand new in 2008-9. But with a long-term goal of like, let me try to architect this as a computer scientist correctly so it has the potential to scale. And let me put it out there on GitHub, which back then was brand new. I think emerged around the time, initially it wasn't even GitHub, and see if others find this useful. And so throughout my career, I've always tried to solve the problem in front of me for myself, but also to see who else can benefit from this. And so if you take that approach, then I've also created the original Pixhawk electronics, ground control, a few other things. And guess what? Me coming to Ukraine was actually like, okay, so you are building your own FPV drones, but you're building them in similar sizes. And, not necessary for all the FPVs because they're FPV specific protocols, but all the like plane loitering munitions and others, you're using that protocol. So if we look at the Ukrainian drone industry and even at the Western drone industry, there is much more system integration going on of standard components and open source technology than initially meets the eye. So it's not like all these companies are building everything from scratch and they have competing technology stacks and it's all their IP. No, it's actually mostly buying parts with open source software and putting them together. And so when I looked around, what I actually found is a relatively high level of standardization of the supply chain. And that allows us to fit in because what we do as a company is inspired by the same standards that I've set back then as a developer, set by standards that some other people have been setting. And so some of the FPV, like for example, mechanical parts, they're almost like a Picatinny rail. It's like it fits into each other. There are hole patterns. It's like, and all these companies building things from these standard parts. And so what I found is actually like, there is a standard form factor emerging, and we as a company can fit in there and go beyond what's available in that, I would say, hobby market, and provide military capability in the form of terminal guidance with a specific application that we have developed for warfare. And that is not just a integration of existing or recombination of existing parts.
So I want to come to the supply chain because that is something, because you say you work with the Department of Defense, and I would say there's been a considerable shift in how at least the U.S. thinks about the supply chain in general, right? And then the FPV, or let's say the broader drone industry, has extreme links to China, right? This is an outgrowth in many cases, as you said, of the hobby industry. And China makes a lot of these sort of cheap electrical components that allows you to build these FPVs for affordable prices. Tell me a little bit about sort of how you think about the Chinese role in the supply chain. And I know, because we've had conversations before this, like you want to aspire to something different.
I think there are two levels of Chinese supply chain. There is I would call it the hobby supply chain, where China dominated the FPV hobby market and has initially supplied Ukraine. There are now Chinese export controls in place that have slowed that, and there have been more domestic designs on frames and other parts by Ukrainian companies and by Western companies. So that's a part of supply chain where I would call that where China was dominating, and it's easy to replace. Easy as in you can move off that, and us providing avionics that's not made in China and that's more capable, and that includes an AI processor as part of that. So that's something we've been building momentum for over the last 5-7 years. The part where I also think we are in a good spot, but it's harder and it requires government investment and, quite frankly, DoD and NATO allies to buy stuff, so there is a throughput and a supply chain, is for the more sophisticated components. Cameras, gimbals, things that the Chinese market leader DJI makes at great scale and low cost, where, quite frankly, we need government demand on a similar scale to compete. And I think there we still have some work to do. I had a very interesting meeting at a government conference, I think it was 1.5 years ago, where they asked me, and it was a number of government customers from all sorts of agencies, also beyond DoD, and they were like, why can't we buy something that's roughly the same price? And I countered that with a question of like, how many would you buy? Well, 500. And I'm like, in order to get to that price, you probably need to buy 100,000 or 1 million. And they were like, oh. So it goes back to that basic principle. Fast forward to today, that is not an issue anymore, because if you look at the throughput that Ukraine has in loitering munitions, FPV drones, now we have to deliver for NATO and for Marine Corps and for Army at much greater scale, thanks to the current administration changes, the budgets are in place. And so I'm less worried about that, and it has become a pure execution question, and we feel good about that.
You're also thinking about the Indo-Pacific context here. So I want to start by saying, in your observations from your trips to Ukraine, in the application of your products in Ukraine, what are you seeing as sort of the 30,000-foot sort of meta lessons? And then we'll come next to how you're thinking about applying them to the Indo-Pacific, which is obviously very different, because while Ukraine, I believe, is the second largest country in Europe by landmass after Russia, if you include Russia in Europe, the Indo-Pacific is far larger, obviously, than both combined.
I think there are two fundamental things. Let me start with the good question that is getting a lot of attention right now. But Ukraine is fighting differently than we will fight. And
I heard it this morning on a podcast I was listening to, the Defense and Aerospace Report. Even though they're not plugging this podcast, I was listening to it this morning while making breakfast, and they said exactly that. That was the takeaway from the recent air show in the UK.
Yeah, and so the short, like my view on that, and it's probably aligned with voices that you will hear from the battlefield, is yes, we will fight completely differently, but we will still fight with drones. And so for example, we're building technology that allows one soldier to put 10 or more drones onto a single target, single armored column. So there's a massive force multiplier. I don't think that NATO soldiers will become all skilled FPV pilots. That is actually not a force multiplier, it's a force divider. We don't want that. We don't need that. We don't have enough soldiers already. So we need technology to augment, not to replace. So that there are huge differences. In terms of drones, I think that the two biggest misconceptions I'm seeing in the West is, number one, that they have a certain range, and the range is the range and it's hard to change. No, it's actually not hard to change. You can go to a different airframe, you can extend the range. And so, for example, we have a partner that makes a drone that can carry a 20 to 40 kilogram warhead. A Harpoon anti-ship warhead is 63 kilograms. So it's that's not far off, over 1,000 miles. And if you guide that drone initially with satellite imagery into the right area of operations, you can go hunt for ships totally with that system.
That sounds a lot like early generations of cruise missiles with the terrain matching, or I guess satellite image matching as your guidance. Do I have that right?
Yes. Now, just that system is in the hundreds of thousands, and right, if you want to push it to the extreme end, under 100K, and has much lower requirements for launching than a cruise missile. And so suddenly we're talking about 100x in reduction of cost for the same capability. Mm-hmm. And now you can afford thousands of them, and you can launch thousands of them at the same time. And so I think that is technology that we originally built for the theater in Europe, and it completely applies. And we have customers that have engaged naval targets already. So it's not even a hypothetical. It's we've done that. There are also new modes of operation, like you launch smaller drones from an autonomous boat. And so you basically get the boat within, like a mini aircraft carrier, you get the boat within strike distance, but outside of detection distance of enemy naval forces. And then you take out their radars. And after you're done with the radars, now because they can't engage now naval targets anymore because they can't see, you're now engaging the ship with the unmanned surface vehicle itself. Because they're now down to basically soldiers with Browning machine guns as their only ship defense. So these are real world scenarios where drones will absolutely scale to the Indo-Pacific and where they are changing the battlefield. And unfortunately, on both sides, right? The same offensive capability that I'm now talking about, China will be learning and other nations will be learning.
I'm going to ask you a slightly nerdy question because it's my podcast and I can do that. Do the naval targets actually make this easier because it's flat terrain and you just have a big thing against the horizon?
Yes.
Versus, let's say, an amphibious landing of Taiwan by the Chinese, you have mountains and then you have clutter that would be on the ground, an urban environment, let's say.
Yep.
So does the naval aspects of this actually make that job that you were just talking about an easier thing to do than, say, fighting in Mosul or fighting in Taipei?
It makes it way easier. On a thermal camera, it's really easy to spot ships. You have most likely a certain area where you know there's a concentration of enemy assets and there is no civilian and none of your own. And you can even literally employ really dumb strategies like a lawnmower sweeping an area.
Yeah.
Until you find something. And so I think we might see drones to be even more problematic and effective in a naval environment than on land.
Yeah, I mean, that makes sense to me because, again, I have a more background in cruise missiles, to be honest with you, but the cruise missile guidance over water is easier than cruise missile guidance over land. And when you think about those early systems like Tomahawk from the early 1990s, one of the challenges the U.S. at least had in Iraq was Iraq is very flat, basically at the entry point. And so the cruise missiles would lose terrain matching points and go stupid and clobber. And so obviously there's been iterations in guidance moving forward, but you can think about the same applications there.
Maybe to complete the argument, from a force design perspective, you can hide jammers relatively well that are hard to find with cheap sensors. I mean, we're changing that. We're investing into spectrum scanning. But in general, you can dig in a jammer over land and you can heavily fortify it and protect it. And it's going to be hard to engage with drones. Hard to find and hard to engage. Over water, that is a totally different story. Right. Because the jammer will be on a vessel. The vessel is easy to find in the thermal spectrum, and you can fly towards a signal. And then in the wide open sea, you'll find the source of radiation. So unless you find a way to disrupt GPS satellites completely, I'm not actually sure if GPS will be as jammed, because it's like in Ukraine, there is no GPS signal. You have to operate completely without GPS. I could see in a naval scenario, GPS to actually be available. And when it's not, you have a target. And so that's another big difference that makes the problem set potentially even easier.
So that was actually going to be my next question. I assume that your terminal guidance either relies on, I don't think I'm giving away any secrets. It's either probably 5G, sort of like pinging off of mobile towers, or GPS. Is not the necessary or the likely response, and I'm curious if the Russians are doing this, is to either jam your 5G or to jam your GPS to make harder that final terminal guidance stage when there's also huge RF jamming as well going on in the battle space. And I'm certain you've thought about all this, what you've viewed or lessons learned from Ukraine, because there's always talk about in the US operating in GPS jammed environments.
We're actually already a little further than that. We do not rely on GPS at all. GPS basically does not exist in our operations. The way the current generation works, and we do have a full ATR version that we deploy soon. The current generation works, you you have a video feed to the operator, and we have different radio links, different price points that we use from third parties. It's roughly 20 to, I think, on the edge, 40 miles around that range. And then you can lock onto the target. The optics allow you to lock onto the target from about a mile. But you never need GPS at no point in the operation. And GPS is easy to jam because the satellites are so far away. It's way harder to jam a video transmission that's, in our case, frequency hopping, encrypted, designed to be hard to jam. It's not impossible, but hard. And if you are far away from the target, even if the target has a local jammer, it's not loud enough from a mile away to take out your video link. And that's how we get through jamming, by basically locking onto the target. And then if the video signal to the operator gets jammed half a mile in, we don't care because we're already locked onto the target and it's going to get destroyed. And so in that mode of operation, we don't care about GPS. We don't need it. We navigate with terrain. But in the naval operation, of course, the terrain navigation would be a concern. The question is just, can you defend your jammers well enough? Or are they so easy targets that actually a lot of these systems can still rely on satellite navigation? I wouldn't advise to do force design based on that. It's too risky. But I personally would not, if I'm speculating, I would not be surprised if, in fact, it actually is an option.
Yeah, it makes me think of the Maverick missile, again, just going back to the early 90s in terms of its guidance. I assume that if you shorten the distance of the initial television signal needs to be sent, you can have more fidelity or get closer to the target. So if you have secondary systems that are either higher in the air as your repeater, you could perhaps control more or have more efficacy on those FPVs. Well, I learned something today. Well, that's really interesting. When we talked, you said you don't view FPVs as, again, something to replace air power or anything along those lines. You see them as something that's just naturally happening, right? In that the next war, regardless, in the next war that will be fought, some version of FPVs will be used. I know you've thought a lot about the Taiwan scenario, so can you just walk us through at least your Ghost fleet, geo futures, thinking about what this combat will look like?
I think there's two stages of deterrence that are relevant in the Indo-Pacific. The first stage is what we just discussed, like how easy of a target is a fleet over water, and where do you launch from, and what range of systems do you need, and which pre-warning. And I think that in itself is already a pretty interesting scenario, because you can, even with dead reckoning without GPS, you can get pretty close. And if you send enough systems, and I'm talking about a few thousand, you have enough to disable or sink a pretty significant fleet. So that's stage one of any deterrence operation, and it would already be quite high, very costly to push through that for an invading force. And in general, I think drones right now tip the scale to the benefit of the defender. And I think it will need massive investments in technology and some breakthrough moments for the offensive part to get back into the same balance as it was like 3 years ago or so. Now, that's stage one. Stage two, if you can't prevent, if the enemy objective is a landing and you can't prevent every vessel from arriving, now we're looking at a scenario that is much closer to the scenarios in the Donbass, because you're seeing a defending force fighting from the covers of an urban environment with fortified concrete structures, with like hard to penetrate. In the case of Taiwan, it's pretty hilly. I've been there quite a few times recently for obvious reasons, and so that's actually terrain that is relatively well to defend in a drone warfare scenario, because you can launch from places, you have cover, and now it's a war of attrition, very much like in the frontline cities in Donbass. And that part of a potential conflict would be incredibly close to what we're seeing in eastern Ukraine right now.
Right. So you're thinking about it in two separate ways. One, there's the naval component of it. And then there's really two ways to think about the naval component of it, too. Taiwan is quite close to the mainland of China, where I think you're also thinking about if you're, say, steaming in from the second island chain into the first island chain, there would both be challenges as, let's say, the U.S. Navy coming across the Pacific versus a defending Chinese, and also offensively how the U.S. Navy can operate against defending Chinese in that respect, mm-hmm. or simultaneously conducting offensive operations in Taiwan.
Mm-hmm. Yeah, I think, and if, again, I'm leaping forward here a little bit, but so far, most people who have leapt forward on Ukraine were right. I'm expecting that we will see a much larger naval gray zone where nobody can operate in safely than in any situation in the past, where it might be like 600 miles, like the 30 kilometers, 20 miles in Ukraine, where no major asset survives more than a few hours because it will be found. There's battlefield transparency. It's really, really hard to cross that distance. And so nobody can enter that area successfully, except for if they do a major force push and are willing to go through incredible attrition. And if we're playing that forward on a naval campaign, it would mean that the U.S. standoff capability for roughly that like Shahed operating distance, which mm-hmm. is like dominating here because it's super cheap and there's a reasonable range. So for about 800 miles or so, you would need to have standoff capability, and you can still maybe operate partially with aircraft, but any major naval asset that gets into that area will be found and engaged.
Yeah, and so, outside of the FPV or let's say the drone discussion in general, this is where questions about magazine depth, particularly on standoff munitions, so here we're probably talking Tomahawk or the SM series, as well as available fighters, come into play. An unrefueled range of available fighters, because 800 miles with a full loadout is still a lot for any modern day fighter that the U.S. Navy would carry, either the F-35 or the F-18.
I don't want to wade too deep into Air Force force design discussions because I clearly don't know what I'm talking about there. But I think there's going to be, like, for naval assets themselves, they can be spotted by relatively low cost technology. I think it's a different story to engage a tanker at 30,000 feet or 40,000 feet. Drones might not be that good at that. So maybe it's relatively safe. And then it's a air-to-air. Like the air-to-air combat might be happening at a much closer range mm-hmm. than that. But for the main naval pieces, it's of course harder. But what I firmly believe is that ships will be far easier to find than we think with super low-cost systems. And it will be very, very hard to protect their radars and communication infrastructure from strikes.
Well, we're coming to the end of the show here. So if you wanted to say summarize, I guess, your meta lessons from Ukraine, we may have already hit it, and where you think or where you want this field to go so that Western nations, let's say NATO, are well prepared, to contend with or defend against an adversary with these things, but also have their own to be able to inflict or at least go on offense and not always be on defense.
I think there are two main lessons. Number one is we can expect rapid evolution on the battlefield. So part of our force design needs to be to factor in, like, how can we, and I think DoD is doing a good job at doing that, how can we really stay on our toes when it comes to technology? How do we think about more like, hey, there's a constant refresh, like you're changing your smartphone every 1 or 2 years, of capability? And how do we have enough standardization and common software so that doesn't create chaos? And I think, again, like the fact that there is iOS and Android is a great example. I think that's valid. I think that's really, really important because that will stay. It won't go away. Like, software has entered the realm of defense in full force. And the second piece is, as we're modernizing our forces, shifting from manned to unmanned is really important. We've shifted from cannons to cruise missiles So it's, those shifts have happened before, and now it's really, really important to really ask, like, I think the discussion, like, are aircraft carriers obsolete or are tanks obsolete, is, I think, a little bit besides the point. The point is you need to be able to launch unmanned systems from everything that's in operation right now, and maybe you need some less of a few of those less, but we really need to make sure that spending is where the excitement is, and that we built up our industry by buying enough that companies can actually start to scale. And we're getting out of the analysis paralysis in the Western world that we're sometimes like to be in.
Well, this was certainly a fascinating conversation. I have any number of questions about guidance, but I'm going to leave that for perhaps maybe when we run across each other in the world, and certainly think that there is more that we can do, thinking about this at FPRI and obviously with you about where this situation is going with FPVs, with drones, and sort of the entirety of how the Department of Defense or its partners and allies around the world should outfit the future of their armed forces. So with that, Lorenz, thank you for joining Chain Reaction.
Thank you.
Thanks for joining us on this episode of Behind the Front, a special series of the Chain Reaction podcast at the Foreign Policy Research Institute. To learn more about this and many other initiatives, please visit us at fpr.org. Until next time.